Welcome back, everybody. So we're going to finish up the chain rule notes here, section 2.4. What we're going to look at here is just the remaining examples. We got some table examples. We've got a function example here. Common example, we're going to find the equation of the tangent line like we typically do. So we'll start with that one. So we've got a 10th degree polynomial expression. So y equals 1 plus 2x to the 10th at the point -1, 1. So we can check to see if we plug in -1, we'll get 1. So that's definitely a point on the tangent line, which is good to know. And so we're just going to compute the equation of the tangent line. So we know it's going to be y minus 1 equals some slope value times x plus 1, just using that point slope form. So we just need to figure out what y prime is at -1. So let's go ahead and compute y prime, or dy dx. So y prime then is going to be 10 times 1 plus 2x to the 9th times 2. So note again, that's f prime of g, and that is g prime. So the derivative of 1 plus 2x is 2, and then the derivative of the 10th degree polynomial expression is 10 times that expression to the 9th. So then if we do y prime of 1, we can plug in a 1 there. So we'll get 10 times, -1. Whoops, not 1. We'll get a much larger number if it's 1. So we're going to do y prime of -1. So if we do -1, we'll get 10. 1 plus 2 times -1 is -1 to the 9th times 2. -1 to the 9th is just -1. So we're going to get -20. So our slope is going to be -20. Okay. So again, not necessarily a ton of work with some of these derivatives. They won't be super complicated all the time. And in this case, it works out real nicely to just -20 is the slope. All right, so now we've got a table here on the right with some function values, f prime, g prime. So we've got h of x, lowercase h of x, and then uppercase h of x are the two different compositions, and we want to find the derivative of both at 1. So let's go ahead and do that. So h prime of x will be f prime of g of x times g prime of x. For capital H, it's going to be g prime of f times f prime. So then we just need to plug in all of those different values at 1. So let's go ahead and look at our table here. So what's g of 1? We need to find g of 1. G of 1 is 2. So this is going to be f prime of 2 times g prime of 1. So then f prime of 2 is 5. And g prime of 1 is 6. So we'll get 30 as our answer. Good. Oops. And then we can zoom out a bit here. So then capital H prime of 1 is going to be g prime f of 1 times f prime of 1. So what is f of 1? F of 1 is 3. So we got g prime of 3, f prime of 1. So g prime of 3 is 9, and f prime of 1 is 4. And we get 36. So again, just a table example representing our chain rule. And we should also look at a graphical example for sure. So we've got f and g graphed here. Let's see what we get. All right, so we've got u is f of g. V is g of f. And then w is g of g. So we're going to compose g with itself. Perfect. And we want to find the derivative at 1, I believe. So let's go ahead and compute those functions. Yeah, so On your notes, it should say at x equals 1. All right, so let's go ahead and compute those. So for u prime of x is going to be f prime of g times g prime. So u prime of 1 will be f prime of g of 1 times g prime of x, g prime of 1. For v prime of x is going to be g prime of f times f prime. So v prime of 1 is going to be g prime of f of 1 times f prime of 1. And then w prime of x is going to be g prime of g of x times g prime of x. So w prime of 1 will be g prime g of 1 times g prime of 1. Okay. So let's see if we can do some computations here. So g of 1, what is g of 1? G of 1 is 3 times, and then g prime of 1. All right, so let's go ahead and look at our slopes here. So f prime of 3 is going to be, let's use a different color. It's going to be this line, which looks like it's negative 1/4. And then g prime of 1 is going to be on this line, which looks like it is 4/2, so 2. So we should get negative 1/2. Good. And then v prime of 1 is going to be f of 1. F of 1, let's go ahead and get rid of that for a moment. Oops. Got rid of too much there. So f of 1 is 2. It's going to be g prime of 2 times f prime of 1. So if I look at g prime of 2, that is a cusp. So that does not exist. Yeah, so we get an interesting result there. We've got a cusp at x equals 2. Good. And then finally for w prime of 1, so g of 1 again is 2, so we get g prime of 2 again, times g prime of 1, so that also does not exist for the same reason. So our composition is not differentiable at that point. Okay, so again, a variety of examples involving the chain rule here. And again, like the product and quotient rule, it's going to be one of those things where the more you practice it, the better you're going to get at it. So definitely come by if you have questions. Send me an email if you can't come by office hours.